everyone, Andy from eTeknix here, and I wanted to make this video because I feel it's very, very important. There's been a lot of information flying around about ATX 3.0 PSUs, about PCI Express 5.0 connectors, and some of the harm or potential harm that they could do. So I'm joined here by Mr. JonnyGURU himself, JonnyGURU from Corsair.
Hey, Andy.
And I guess the whole point of this video is to dispel a lot of myths that are floating around. You've probably heard a lot anyway, right?
Oh yeah. All week.
So yeah, us for like as media, we hear a lot of chatter. You know, we try to keep our ear to the ground on social media, on Reddit, as much as it pains us to be on Reddit, and you know, dealing with that, we have to. And obviously you've been hearing it. I guess you've been hearing it from potential customers, from resellers, from all sorts of people, right?
Right, because they're all reading the same stuff. Yep.
So what we've actually done is I've compiled a list of questions. We're just going to go through them and try and, I guess, go down the route of having pure clarification for people who are going to be buying new graphics cards that are going to need a PCI Express 5.0 connector, what it's all about, how that differs to the ATX 3.0 spec, and just, yeah, dispel these myths and try and get some clear clarification from the man himself. So I guess, yeah, let's get into it.
Sure.
The main one is, what is the deal with the PCI Express 5.0 power connector?
That's a really easy one. Basically, NVIDIA just wanted to be able to say that you could deliver more power with a smaller connector. So not that the old connector was not capable, just that it was specified for a lower power rating. So, and, you know, if you look at the two side by side, they're really the same size, but one is 8-pin and the other is 12-pin. So they just wanted something that was a smaller footprint instead of asking AIBs to, you know, put like 3 or 4 of the 8-pins on there. It was using up too much PCB space, and I think they wanted that PCB space for something else.
Yeah, because obviously we know with NVIDIA Founders cards, they are much, much smaller than most graphics cards out there on the market. So space, I guess, yeah, does come at a premium. I mean, I've got one of the cables here, and I actually remember a brand sending me a power supply. I'll try and keep it generic, but a brand did send me a power supply, which came with a PCI Express 5.0 connector. It wasn't, because it was missing the top 4 pins, which I think the main thing there is that they're to do with sensing. Is that right?
Well, okay, so it's still the same 12-pin, and NVIDIA just wanted to stick with the 12-pin. But you know, when you make changes like that, you have to send it to the PCI-SIG consortium, and then when you send something like that to a consortium, you get a bunch of other people providing input, and those other people started adding things like the sense pins. So if this was just you know, completely agnostic and just NVIDIA saying, all right, let's roll with this, we'd still have the 12-pin.
Gotcha. Okay. So there are reasons, but I don't know, from my standpoint, I'm just going to see it as NVIDIA wanted to do something. So I guess the manufacturers who work with NVIDIA have to do something to comply with that. Otherwise,
you have to standardize this stuff or everybody goes rogue. Yeah.
But obviously, we're talking about NVIDIA. I'm not hearing anything coming from you in regards to AMD. So it does seem like this is an NVIDIA, not an issue.
Well, so yeah, I've been in discussion with NVIDIA about this stuff for like over a year, right? We've been going back and forth, but AMD is really have not said anything about what they're going to do. Now that said, you know, it's my understanding that nobody is really ready with a PCIe 5.0 graphics card as far as bandwidth goes. Yeah. This is just a power delivery definition, right? So while we're calling it PCIe 5.0, we're still working with cards that are PCIe 4.0, but they're kind of doing this migration thing to where they're adopting a new power standard for PCIe 5.0 that, because it's in the PCI-SIG now, once cards are PCIe 5.0, you're going to see that power connector everywhere.
Yeah, because I actually, we had a briefing with NVIDIA the other day, and virtual editors day, and one of the questions I asked was, why have you not gone PCI Express 5.0 with the new 40 series cards? And their whole reasoning, just like you confirmed, is we haven't even hit the bandwidth of PCI Express 4.0 yet. So
exactly. Yeah.
But I guess with anything, it's chicken and the egg. The motherboards have to have it ready for when these cards do come and things like that.
Yep.
So
it's a transition thing more than anything. Yeah.
I guess it's a weird one. Calling it a PCI Express 5.0 connector, there's technically nothing 5.0 about it, right?
Right. It's just a new connector.
Yeah. So I guess we've touched on it a little bit, but yeah, how does it differ to what we've seen on the likes of a 3090 Ti? As like I say, it looks the same, but it's got 4 extra pins on there.
Right.
I mean, can this be plugged into that? Can that be plugged into that?
It can be, and I haven't had a chance to experiment with 4090 yet because we just got ours in on Friday. But supposedly, if it doesn't have the 2 sense pins, the sense 0 and sense 1, the card doesn't power up, which is different than what it says in the Intel spec and the PCIe-SIG spec, where it says that if it doesn't see those sense wires, the card is supposed to underclock.
Right.
Which would be cool, right? Because like if you could only support 450, then the card doesn't, try to run too fast. But,
well, especially with, I know America's not had it as bad as we've had it over here, but the price of electricity going up and things like that. If you could technically like undervolt your card just through, using a different connector.
Think about it. It'd be like an automatic underclock. That would be awesome. Just like, okay, well, I don't need this card to produce this much power right now, so we just use a cable without the sense pins or less sense pins or whatever, and the card knows that it's a lower power. But unfortunately, that doesn't seem to be the case.
No,
at least from what I've heard from NVIDIA.
Yeah, which would be interesting because the way that things are going, like AMD's just unveiled their Ryzen 7000 series, which actually have an eco mode. So they're trying to really appeal to this, this market of wanting to underclock their cards, still getting great performance, but for a lot less power. I don't know, maybe something future in the pipeline. Who knows? It's NVIDIA.
That'd be cool. Yeah, we'll wait. We'll see.
So I guess next question would be, for those using a power supply that doesn't specifically have the PCI Express 5.0 connector, are there any issues with the adapters? I mean, I've got an adapter here, which is typically what came with Founders Editions and the 30 series. Obviously, it's missing the 4 pins, but the other ones look basically the same as this, just have the extra 4 pins. Are there any issues? Because this is the main thing that we're hearing about. Power supplies blowing up, and
nobody's actually reported any issues whatsoever with those. Now, personally, I'm not a big fan of extensions and adapters, but that's just because you're adding that additional point of failure with having the the connectors in the middle, right? And also you're extending the cable, which obviously is added resistance there. But that's why they put 3 8-pin connectors on the one in your hand, and some of the newer ones have 4. Not that it needs that much power, but what they're doing is they're putting in redundancy for failure, right? So like if you have like, say, half the terminals, which is like an extreme, but let's go to the extreme, half the terminals are not seated properly, you still have enough power capability with the other half of the terminals, right? So you literally have double the capacity with the cable with the 4 connectors on it.
Okay. I mean, we'll get to kind of what the capacity of 8-pin connectors are, because I know that's a little bit of a gray area and stuff as well.
Yeah.
But I'm guessing another reason would be to do with, and we experienced this with the high-end 30 series with transient spikes. And, when we get these high loads, when a computer first boots up and then comes back down, I'm guessing that's giving you the overhead for that as well, right?
No, not at all, actually, because those spikes are so fast that it doesn't, the cable, the connectors, the terminals, even the components inside the power supply don't even see it until it's like beyond a certain amount. Like, for example, supervisor IC doesn't typically trip until 100 microseconds. So it has nothing to do with that. Everything is rated at a static or continuous load. You can have these transients as fast as they are, and it doesn't matter how many conductors you have.
Okay.
It doesn't make any difference whatsoever, because like I said, the power delivery is so fast. The transients are so fast that it doesn't have enough time to create enough resistance to drop the voltage.
So I guess then the definitive answer is, while you, I guess personally, don't like adapters because you are adding in another variable, which is another point of failure, you'd like to think, with all these brands, so we're talking, I mean, the main one that has been going around that we've seen pictures of is from Zotac. You'd like to think that these brands have been in the industry for so long that they're not going to release something with an adapter that's going to have these problems,
Yeah, they've been testing this stuff for ages, and ages. Yeah, and they know. And like I said, they could have just like full-heartedly just went with a 1 to 2 adapter and then 2 to the PSU, and that would work. But there's still that liability there. So best, why not put in 3 or 4, right? It's, again, like I said, it's redundancy. You're just beefing it up to make sure there's absolutely no issues whatsoever.
Gotcha. And obviously, we don't know at the moment until we see sort of full specs and testing capabilities of what these cards can do at full load. But based on not just yourselves at Corsair, but other manufacturers, we have seen a little bit of a shift. I remember when a range of power supplies would come out, you'd get like 550 up to 850. Now it's more like 650 up to 1350. I'm guessing that's just preparation for these.
Yeah, I mean, now actually it's more like, what we've seen very recently is like 750 to 1200, right?
Yeah,
So.
there's definitely been sort of a change up with that. So yeah, with those adapters, they typically go from multiple 8-pin connectors. So what's the deal with 8-pin connectors in general? We were chatting about this the other day, off stream and everything. And I guess there's a really big bit of confusion that an 8-pin connector gives you 150 watts of power. A 6-pin gives you 75 watts. And then obviously you have the power from the slot itself.
Right.
That's not strictly true, is it? There's a little bit more to it.
Yeah, so that was a spec that was developed by NVIDIA like 15 years ago. And basically what they were trying to do is define the different power levels of cards, right?
Yeah.
So what they were saying is if it has a 6-pin connector on it, that's a card that needs 75 watts of power there. If it has an 8-pin connector on it, that's a card that needs 150 watts of power there. It's not the limitation of the connector itself. It was just a definition for the cards, right?
Yeah.
So if you want to think about it really logically here, you only have like two 12-volt pins on a PCI Express connector and some grounds, right?
Yeah.
Now you use those 4 pins, compare that to a 6-pin PCIe connector, and you think about it. Do you really think that 6-pin PCIe connector can't supply more power than those 4 pins in the slot? And then to take that further, look at what an 8-pin PCIe connector is. It's 6 pins for power, right? 312, 3 ground, and then 2 sense wires. Well, you don't magically double the capacity of a connector just by adding 2 sense wires. It's still the same connector, right?
It's still the same number of terminations. Yeah, exactly.
Yeah. So if you actually were to look at the spec for the connector, it's actually much higher. So like, for example, if you're using the regular minifit juniors, I'm trying to do this off the top of my head. They're like 7 or 8 amps per terminal with 18 gauge wire.
Yep.
And if you're using what they call the minifit HCS, which stands for high current system, those things are spec for 10 amps per terminal. So if you do the math, and we always do like plus minus 5% for worst case scenarios. So let's say the voltage is 11.4 volts. So if you're using one of the standard like 18 gauge, 8 times 3 is 24, 24 times 11.4, that's going to be 273.6 watts per connector. Yep. For 6 pins, right? And if you're using the HCS connectors, which is what we use, not to brag or anything, I'm just saying that's what we use. You're doing 10 times 3 for the 312 volts times the 11.4 volts. So that's 342 watts per connector. So if you think about it, 2 of those 8 pins actually are capable of way more than the 112 pin.
Yep.
So,
do you think this is why as well? I remember, I've been in this industry a long time, as have yourself. Do you think this is sort of the reason why, we used to see single 12-volt rails, then multiple 12-volt rails, where I think Corsair products are now predominantly just single 12-volt rails, right? So I guess
even if they're multiple, you have the option to switch them.
Yeah. So I guess even with that clarifies, if there was an issue with connectors providing X amount of power, well, you wouldn't be able to do that through a single 12-volt rail. That's why we can say there is more power from these connectors. We don't need multiple to get, so much power from 4 12-volt rails, for instance.
Right.
Yeah, makes sense. So this is the main one. A lot of people have seen videos over the last couple of days. I'm not going to point any blame or anything. We've probably all seen it, but there's been a lot of videos over the last couple of days in regards to failure. And this has predominantly come down to failure on old spec power supplies with adapters and things like that. I mean, what's it all about? Has it been completely blown out of proportion?
It hasn't been blown out of proportion. It was a partial leak that got misinterpreted. So I cringed a lot because I'm a member. Well, I'm not a member, but of course, Corsair's a member of the consortium. So we were on that same email, right? Ooh. And what you'll notice is that the email just says that there's assemblies demonstrating thermal variance. There was nothing in the letter that said anything about adapters, 8 pins, any of that stuff. And the letter is out there now, so you can see it, and you'll notice that it says nothing about that. Yet somehow somebody extrapolated that they were talking about the 8-pin connectors on the adapters, right? Or using 8-pin connectors on the PSU instead of having a, what they call the 12V HPWR connector, right? Yep. What the actual letter was pertaining to, there was an attachment to that letter, and what they were talking about in that attachment was if you take the connector and you bend it too much or too tight of a bend radius, because the terminals are so small, there is a potential that you will have some intermittent contact. Okay, so that is your thermal variance that they were talking about, was the thermal variance within the new connector. Okay, so why didn't they go ahead and like freak out and like delay the 40 series launch and everything? It's because the condition that created that was a less than 30 millimeter bend radius, a 55 amp load continuous on the connector for over 10 hours.
Okay. So 3 different
that
variables.
was also in the PowerPoint that was attached to the email.
So 3 different variables happening at the same time.
Yes.
For a prolonged amount of time as well.
Yes.
It's just the chances of that happening are 0, basically.
Yeah. So what we were doing to test it is we were taking our cables, and we have our test fixtures, the PCB with all the PSU connectors on it. And we were pulling the cable down and zip tying it down, cranking up the 55 amp load and leaving for the weekend.
The building's still there.
And the building's still here. Came back, everything's fine, right? So that's how extreme it is. So basically what they were doing, they're just putting out due diligence, right? They're just saying, hey, we had a report, right? I don't know how many they tested and what the percentage is. We don't need to get into that, but they were just coming out and saying, we had a report of this, and here's the conditions that led up to that. Which is why it wasn't released publicly, which is why NVIDIA didn't delay the 40 series launch, right?
It's like anything, I guess, there has to be things out there to warn people. It's like when you buy a car and it says that it has operating temperatures between this and between that. And generally they are wildly, massively, never going to hit that temperature, never going to hit that temperature. But they have to state it because there is certain regulations and laws and things like that. Because
you have to narrow down those conditions to a finite finite value. Yeah.
But there was one other side to this, and this is a point that you actually raised about the panic over the new connector only being able to handle 30 mating cycles.
Right, which is the same as a Molex MiniFit Junior, which is what we use today for 6-pin, 8-pin PCIe, everything else.
And it's fine.
It's 30 cycles. And again, it's just like that whole thing with the melting connectors, right? Where they're just doing their due diligence and they're testing to the maximum parameters. So that 30 mating cycle thing again is done it. They unplug it, plug it back in, 55 amps, 10 hours, right? And then they do it again, right? And so after 40 cycles, they might have found some samples that had some damage. Right. Some samples. And so that's the whole thing, right? It's some samples after 55 amps for 10 hours. Right. I always say this compared to, I'm a big critic of manufacturers because they make a product which is generally made, and this is through no fault of their own, it's generally made for a consumer to build, and then that is it. Us as reviewers, we're in, out, poking this, doing that, putting a graphics card in, out a million different times. So how many times have you unplugged and plugged in the regular PCIe connector? Probably hundreds of times, right?
I mean, today alone, probably about 20 times. Where we've been doing CPU testing, and guess what? It still works. So it does happen. And if anything was going to break, it would probably be on us reviewers and people who are doing that over and over and over. And yet I've been running eTeknix now for 14 years. It's never happened. So I've never had an issue to that extreme, but we are also not at the same time running something for 10 hours and running it at such an extreme level of power either. So,
but even it's such a low number. I'm going to tell you honestly, on the factory level for Corsair, when we're doing testing and stuff and burn-in and all this other stuff, we don't even replace those cables on the line for 100 cycles, right? So we're even taking it to 100 cycles because, again, it's such a corner case. It's such a long time for such a high power limit or, current. It's just ridiculous.
Yeah. And obviously you work at Corsair. I'm going to be very generic about, there are other brands on the market. And I remember brands back in the day like Q-Tech, who, I remember power supplies blowing up, this, that, and the other. Compared to now, manufacturers, or let's call them brands, because they generally buy from an OEM of some kind, power supplies are a lot better than what they used to be back in the sort of late 90s, early 2000s and things like that. So when you do hear about these problems, I guess like with anything, buy a reputable brand like Corsair, you're going to be okay. It's as simple as that. So, you know, my sort of daily dose of advice to the people watching this. Now, there is one other thing which I guess comes down to confusion, because
Yeah.
PCI Express 5.0, which is confusing in its own right because it's nothing to do with PCI Express 5.
Right.
The other part, and this is where I think more confusion kind of came into it, was ATX 3.0. Now, I think what's actually happening is because of some of these videos and some of these pieces of content, there's people out there confusing ATX 5, sorry, ATX
so you're doing it now.
I know, and PCI Express 5.0, they are seeing them as one and the same.
Right, but they're two different things. So like PCIe 5.0 came first, right? Yeah. And then when Intel saw that, they said, okay, well, let's implement that into a new ATX standard. Yeah. And so they grabbed that and they merged it in and made it ATX 3.0. A lot of the stuff that's in ATX 3.0 is actually not new. So for example, I mean, I could go down the list because we've been doing this for years. So they have a timing requirement for ALPM, which is alternative low power mode. It used to be called modern standby mode. Yep. But don't confuse it with the aggressive link power management. I can't stand that they both have ALPM as the initials. Yeah. They should have just stuck with modern standby mode. But anyway, so that was easy because that was just changing the timings on the supervisor IC. T1 and T3 are shorter timings. So that's done, right? And then the 2% load efficiency requirement, again, for most power supplies, certainly here, done, because of the whole CEC thing. If you remember the California Environmental Consortium or whatever it's called, you know, they had this thing where if you're SI, you have to have at least an 80 plus gold power supply. That is at least 70% efficient at 2% load. Yeah, so that's old news too, right? So, and then they added this thing where they're like, okay, well, the nominal voltage doesn't have to be 12 volts. It can be 12.2 volts. And then it could be allowed to drop 8% instead of just 5%, which would bring you down to 12.1 volts. They did that so like less, what do you want to say? Lesser PSUs, I guess I could say. Yeah. You know, the ones that don't have as tight voltage tolerance can still be able to pass the ATX 3.0, right? Because if your nominal is 12 and it drops 5 under the transient load, which is what they're talking about, is at the transient load, if it drops that much, it would be a fail. But it would be a fail for a lot of power supplies out there. So they just relax that. So all that is a spec relaxation, okay? And then the other thing was, and this is new, but it does have to do with modern standby mode, I'm going to call it that, is the 175,200 per year power cycles, which means your PC is turning on and off again every 180 seconds, which is something we found you can test. There's Passmark has a software called Sleeper. Yep. And you can have Sleeper sit there and make your PC just go boom, 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 and turn off and on and off and on and off and on. That was new, right? It wasn't a new spec. It's something that motherboard partners have been testing all along, which is how I found out about it. But then ASUS said, well, if the motherboard partners are doing this, let's put it in the spec, right? So it's one of those things, you know, just like when they saw PCIe 5.0 power connectors, they saw it and they said, okay, let's put it in the spec. That's all they're doing. They're not creating anything new. They're just adopting what's already out there, right? So the only thing that's really new is what they call the 3.0 test plan. And that's what you're seeing when they're saying that your power supply has to support 2 times its rating, which is, it's kind of silly, right? In my opinion, I'll put it out there. So if you have a 1200 watt power supply, it needs to support a 2400 watt power excursion. And what the logic was behind that at Intel was they were saying if you had a 600 watt GPU, I mean, okay, let's put it this way. So they work backwards. They don't look at the components you're going to use and then apply the test plan. They look at your power supply and assume what your system's going to be. So you're buying a 1200 watt power supply. So the assumption is you have a 600 watt GPU, a 300 watt CPU, and then the rest of your system, your drives, your fans, everything else is also 300 watts, therefore totaling 1200 watts. Therefore, a potential power excursion could be 2400 watts. So again, it's another corner case thing, right? Where it's like, okay, you're going to really have a 600 watt GPU, 300 watt CPU, and 300 watt rest of system, and everything is going to have a transient spike of 2 times the PSU's capability at the same time. Probably not.
It seems a bit silly, doesn't it? Yeah, that's basically like I mean, we do tests sometimes where we put our GPU and our CPU at 100% load. You know, we use Prime 95, we use Fairmark, something that's going to raise up your drives and everything. Nothing is going to go that high at the same time for a prolonged amount of time again. So I do the same thing. I run Fairmark, Prime 95, and Linpack Extreme all at the same time,
right?
Yeah.
To just torture the heck out of it, pound on the space bar to make the furry donut go off and on, right?
Yeah.
And just watch the power spikes, and it's non-consequential. Yeah, there's nothing there.
So I guess with the ATX 3.0 PSU, for anyone who doesn't know, if you're going to buy that, it's going to have the PCI Express 5.0 connector, right? Because it is now part of the spec.
It's because it's part of the spec, right?
Yeah.
Right.
So,
but the thing is again, it's like it's not something that you necessarily need, and it really kind of torques me a little bit, because like I said, we've been talking to NVIDIA for over a year about this thing, and we made a decision not to put the connector on the PSU, and they were fine with that. So yeah, I could if I could come up with reasons, it would behoove me to come up with reasons to make people go out and buy new power supplies, right? It's revenue for Corsair.
Yeah.
But then you're also creating a bunch of e-waste for what? The person just bought a 1200 watt power supply, and now you're telling them that they need to buy another 1200 watt power supply that's exactly the same, but has the connector on it.
Yeah. So we're running tight on time, so we will get to the last one, because I think we've pretty much clarified every point. Okay. The last one, just for kind of giggles, are there any other funny pieces of confusion that you've seen over the years that have kind of, been at the same level as this?
All the time, because PSUs are so, it's like the magic black box, right? So I see these things on the internet all the time where people are asking these questions that, I think are like, we have the inrush current limiter relay. It makes a click when you turn the PC on and off, right?
Yep.
And people mistake that as an arcing noise, right?
Yeah,
like power arcing, right? Or, you put the RTV in the PSU, like most electronics have, like amplifiers and stuff, to keep the heavy parts down and also dampen some coil whine. Somebody looks inside their PSU and they see this white goop or gray or black or whatever color it is, and they say, oh my gosh, my capacitors are leaking.
Blown up. Yep. Yeah.
Or for quality control, you take a Sharpie marker, right? After you test a cable, you take a Sharpie marker, you mark it here so it can't be seen once it's installed. Yep. But then a customer sees that black mark, they don't know what it is, and they're like, oh my gosh, this new cable has a burn mark on it.
Yeah.
So I could go on and on all day, but I know we got limited time. So
again, we've seen lots of stuff in the past. We've been in the industry, both of us, for a very long time. It won't be, the last time that this happens, but I'm just glad that we had a chance to clarify this, because I know Corsair are reaching out to other outlets and trying to clarify the issues, or the non-issues, should we say, with all of the hubbub that's out there. But we wanted to get it, I guess, direct from the horse's mouth. So yeah, thank you, I guess, for clarifying everything. And we're eager to see Corsair coming out with these new power supplies that are ATX 3.0 and have the PCI Express 5.0 connector. I know there's no word on when that's happening, but yourselves and other brands are releasing products, these types of products in the near future. So thanks for joining us, John. It's been great, and hopefully next time I see you, we'll be at a show.
I was gonna say, I haven't seen you in so long. It's good to see you again.
So
right, cool.
Thank you very much, and hopefully you guys enjoyed this video. Hopefully it's given you a bit of an idea as to, you got nothing to worry about. And yeah, if you did like this video, a like and a sub to the channel would be amazing, and I'll see you in the next one. See you later, guys. Bye bye.